Hello, this is a video to explain the blueprints in the Puppeteer plugin that I put on GitHub. I felt a bit bad when I started seeing people using it, and I've kind of just put this thing together, chucked it on GitHub, and sort of let people go at it. So given that I was surprised that people actually started to use it, which is pretty cool, I thought I'd explain some of the blueprints because a lot of it's not finished, and so you're just going to need to rip it to pieces to kind of apply it to what you want to do. So if I explain some of the blueprints, hopefully you'll be able to pull out the bits that you need to make it work. So if we look at what we've got here, I've got the main level open. In the main level, we've got a couple of main things that we want to be aware of. We've got the Puppeteer actor and the user blueprint. Now the user blueprint, all it is the camera setup. This doesn't need to exist in here if you do it in the level blueprint. So if I open up the level blueprint, you'll see here, we start playing and we're just possessing the user blueprint actor. Actually, that's a pawn, user blueprint pawn. So we're getting player controller 0, which is our player, our local player, and we're possessing that pawn. Now, you don't need to do that, but if you look inside the user blueprint, all it's doing is it's got a camera in it, and the camera has a whole bunch of settings that I had set up for looking at the digital human. So you'll have your own camera and your own level setups. But in the blueprint, all we're doing is when you press 1, it is creating a Calibration UI widget for the player controller that we've currently, that's for us. We're getting a reference to, saving a reference to it, and then we're adding it to the viewport. And then every other time you press 1, we're just toggling the visibility of it from visible to hidden, hidden to visible. Now, all this stuff here can be done in the level blueprint, so you don't even need a user blueprint. Now, the camera, you would just set up a camera in the level. So in the level, and then you just set view target for the player controller to be that camera if that's what you want to do. If you're using Sequencer, you will be able to just spawn the cameras in Sequencer, and the Puppeteer actor, so the Metahuman, should be operating independent of what you do with the cameras. Now, if we go to the Puppeteer actor, in the details pane, you've got the Metahuman actor class, which is the standard blueprint that comes with the Metahuman when you import it, and you've got the Live Link subject, and this should be the name of your phone, your iPhone. So if we go into Puppeteer actor and we look at the event graph, we can see what happens here. So the Puppeteer actor is where the Metahuman is created, and then we set up the references, the animation blueprint, as well as process the values that come through. So first of all, if you start at event begin play, as soon as you begin play, we are spawning the Metahuman. So based on the actor class that you set in the details pane of the level editor, I've rotated the digital human as well to face towards the camera, but you may not need to depending on where your camera is. And then we're setting a reference to that Metahuman actor so we can use it later. Then we initialize so there's dictionaries. So there's the ARKit blend shape min and ARKit blend shape max. So in the interface, you've got the minimum range and the maximum range for ARKit blend shapes. So we're just initializing to a default value of 0 and 1. And we're going through each of the Apple ARKit blend shapes. Now that list of enums, enumerators, is in here. So you've got a enums folder, which the Puppeteer content is exactly the same as what I've got here. You've got the enums folder. You double click on this list of enumerators, and this is the complete list of ARKit blend shapes that comes with Apple. So it's all here. I've just written them in manually. So we loop through each one, set the min to 0, set the max to 1, and then also make sure they're all enabled. So this is another dictionary where for each ARKit blend shape, we have a Boolean value to say whether it's enabled or not, like whether we're using it or not. Then we set up the animation blueprint stuff. So we get the reference to the Metahuman actor, and then we get components by class. So we get all the skeletal meshes. There's a few of them. There's a body, face. Is it just the body and face? It might just be body and face, not a few of them. We get the display name, and we are looking for the one that's called face. If we find the one that's called face, we set the anim instance class for that skeletal mesh component to be the Puppeteer animation blueprint, because when it comes out by default is using the face animation blueprint, which is the default one that comes with Metahuman. And then we're also getting the anim instance of the, we're then getting that anim instance from that blueprint, from that skeletal mesh component, and we're saving a reference to it. Then down here, we've got event tick, and we are evaluating each live link frame and adding the raw values to a map, exactly as the comment I've written. So we evaluate the live link frame, and for each Apple ARKit blend shape, so we're looping through every single blend shape, and for each blend shape, we check, first of all, is it enabled? If it's not enabled, then the raw value for that blend shape, the raw value that we send through the animation blueprint is 0. Otherwise, we get the value from the live link frame, and we add it to our dictionary of raw values. So every ARKit blend shape has a raw float value. Then the next section is we take that raw data and we normalize it to the calibrated range. So I go into this function here. We loop through all the ARKit blend shapes. So this is per tick. We loop through every single one. We find the raw value. What do we got here? So yeah, we find the raw value and we set a local parameter, raw value. We get the minimum value for that particular blend shape, and we set a local value variable, and then we get the max for that particular blend shape and set a local variable. Then we this is the auto calibration thing. Now, auto calibration is, I don't know if you'd want to use it or not. It's okay, but this is automatically setting the minimum and maximum of the range for that ARKit blend shape based on what the raw value is that's coming in. So when it comes in, if the raw value is less than the minimum range, so if your minimum range is set at 0.3 and the minimum value that comes in the raw value is 0.2, it will set the minimum range to match what the raw value is. So at some point, you'll get the range of what the raw values are, and the minimum and maximum will be set to that range. Now, it has funny behavior because some of the min values shouldn't be what they are, so you kind of have to experiment with it a little bit. But the way this works is when you start, you reset all the min and max ranges to 0.5, and then so your max is generally going to be over 0.5 and your min is going to be below 0.5. So then it just kind of starts in the middle and kind of pushes the range out as you use the live link face. Hopefully that makes sense. It's probably a little bit confusing, but the auto calibration one is probably the one feature that I sort of go, it was an experiment. It didn't really work that well, so I haven't played around with it. Okay, so coming back to, we get the values, we get the min, we get the max, and we get the raw value for that particular ARKit blend shape. And then we just do a function which is normalize the range. We've got the raw value, we've got the minimum range and the maximum range, and we're just normalizing raw value. So if it's between 0.3, if the minimum is 0.3 and the max is 1.0, the raw value is 0.6 or something like that, 0.7, halfway in between. Then the normalized value is not 0.6, 0.7. The normalized value is 0.5. So when it goes to the rig, it's halfway between, completely off on the control and fully on the control for that rig. So that goes through to, so that gets added to a new dictionary, ARKit blend shape normalized values. And then what we do is we pass the normalized values to the animation blueprint. So the animation blueprint for the Metahuman doesn't see the raw values, it only sees the normalized values. And I've set here, its target is a Metahuman Puppeteer interface. And the reason why I've done that, it's probably over-engineered for a hack project, but I've set it so that any animation blueprint could implement this interface. And so that animation blueprint that implements that interface needs to have this function, update ARKit blend shape values, so that it doesn't matter what this animation blueprint is, as long as it implements the Metahuman Puppeteer interface, we can fire this function, fire the normalized values to it, and then use it. But like in the case that it's always Metahuman, it's probably not going to make a difference. Okay, right. So that's the Puppeteer actor. Now we need to look at the animation blueprint. So the values are now getting set it through to the animation blueprint. It's a bit slow. There we go. Okay. Well, let's look at this. Start with the event graph and the animation blueprint. So here you've got event update ARKit blend shape values. So this here is just taking the normalized values that are passed from the Puppeteer actor, and then we're setting a local reference or local variable that has all those values. So this is the ARKit blend shape values. So then what we do is every frame, we process those values and drive the rig. So let's just go with browse. Right, so all of the process functions look a bit like this. It comes in and we have a sequence. So the sequence node here is just to reorganize stuff a little bit. Okay. So we are setting, so let's just focus on one thing at a time. Control expressions brow, raise, and left. So the normalized value comes in, So we executed this. So we want to set this control expressions brow, raise, and left. This value is used to drive the Metahuman rig. So before I go through all this, let's just look at the anim graph. This little monster here. So this here is a modify curve node. And so the way Metahuman works is these curve values that are not blend shapes or joint transformations. They're just a curve value. This value is passed through to rig logic, which is running in the post-processing blueprint. That implementation detail is not visible to you. When 3Lateral had their older rigs, the implementation details were a little bit more visible, but when it's integrated into Unreal Engine 5 now, yeah, when it's integrated in, it might be in 4.26 and 2.7 onwards as well, but you can't see the rig logic stuff. You can't actually see exactly what's going on with the DNA files and the rig logic. But long story short, these values get passed to the Metahuman system, and the Metahuman system is converting those into joints and blend shape transformations. So what happens is you can pass it, you can set one of these values, and all the rig logic stuff deals with how the rig should move and all the intermediary blend shapes and all that sort of thing. So what you do in the animation graph, in the anim graph, is you're just setting these values. So we've got all these values here, brown down left, brown down right, all these different values, and this is how we set the values for driving the rig. Now, this is different to the default setup. The default setup uses pose asset, I think it was. Can't remember exactly now. But this is a bit more of a manual way. And the reason why I do it this way is I have control over how much I can drive each control. So you've got all these different controls. There's heaps of controls. I think there's probably about 130 something, if I recall correctly. But it also means that I can drive controls, right? ARKit blend shape gives us 50 odd controls, but the Metahuman rig has over 130. So there's a whole bunch of controls. You can see they're not being driven, but you can infer from, given maybe the lip corner is pulled high and the cheek raise is really high, that maybe we're doing something with the nasolabial fold. So you can infer the value of the nasolabial fold control from two other controls or two other values that you get from the ARKit blend shape. And this is what these functions are. I don't do it for all of them. This is the thing that I said I didn't go all out tweaking it because I just really wanted to have a play to see if I can improve it a little bit. And the answer was yes, but I found that the tracking was a bit limited, so I didn't want to play with it anymore. So in here, if we take this control expressions brow raise in left, let's have a look at what happens here. So we're selecting a value. When smoothing is on, it is taking this pathway and this value, and when it's smoothing it off, it's false. Now, I thought that I would have this Boolean so you could see it before and after. You could turn the smoothing on and off. So in the animation blueprint, you can default the value off, which means that you don't have the smoothing, which is done here, which is the dynamic weighted moving average float. This function is a built-in function from Unreal, and you pass it a current sample, so the current sample of the value, so the current normalized value from the ARKit blend shape, the previous sample, which is the variable, so this is before it's updated, this is the previous frame's value for that control, and then I define a max distance, which is helps this node helps this node to determine whether it should be using the min weight or the max weight. So it is this weight determines it essentially applies a smoothing sort of function to the value that comes out. So when the distance is small, we are using a small amount of smoothing, and when the distance is when the distance is small, we're smoothing it out. When the distance is large, when the value is 1, what I'm basically saying is use the value that you're given rather than doing any smoothing, using the value. So if the brow moves up quickly, we don't want to smooth that movement because we know that movement's intentional. We don't want to smooth it. Now you can play around with these brows weight, average, min, weight. In here, we've got all these variables in here. So you can play with these weight values to get a different degree of smoothing of the movements, which is definitely something to play with because you can possibly get, you don't want to smooth it too much, otherwise it looks too fake. But you also don't want to smooth it too little because you can get little noisy movements. So this is how you adjust the smoothing, is playing with these values. If you mouse over it, it gives you a nice tooltip that explains how it works better than I've done. Right, and then over here, we've got the ARKit blend shape values. So these are the normalized values that come through. We are finding the ARKit, what are we doing? We're finding the ARKit blend shape value for brow and up, and then we are determining, so for brow and up, and then we're smoothing or not, and then setting the brow raise from that ARKit blend shape value. Now you'll notice here that I'm using brow and up for both left and right, because the ARKit shape is just brow and up. It doesn't have brow and up left and right. So what you'll find is you've got, regardless of what the brow left or right is, you can't kind of do independent left and right. Both brows get raised at the same amount. Now you might want to play around with this and adjust the value. So you could do a float multiplier here to reduce the amount that the right eyebrow raises compared to the left-hand side, so you can get some asymmetry and things like that. Because right now, when you raise your brows, it's all the same. You could also do things where if the outer, just thinking how you could get more asymmetry, but that's a question, is how could you get more asymmetry to kind of get it more realistic? So what I've just explained there is pretty much the same for all of them. So all of them have that same sort of logic. There's some smoothing in there. There's some normal, it's taking the values, it's doing some smoothing, and that's it. There are some areas where I do some inference, maybe around the mouth shapes. Let's have a look. So yeah, you can see here, there's a lot of stuff. It looks like there's heaps of stuff going on, but it's all the same thing over and over and over again. So you can see the same thing here. Normalized value coming in, left and right mouth smile, and then I'm smoothing it. And then I'm setting the corner pull control left and corner pull control right. So you might ask the question, well, if ARKit is giving me the smile value, how do I know which control to use on the Metahuman rig? That's where you open Maya and you play with the rig in Maya manually. So you go to the mouth corner pull left, you drag that control, and you're trying to make the mouth smile left value as high as possible in Unreal, like with a live link. And then you go, okay, when I'm trying to make my mouth pull to the side, well, it looks the same as the mouth corner pull control in Maya. And that's how you worked it out. If you've used the facial control rig from 3 laterals digital humans or Metahumans, you kind of know. Okay, so there's some here where I have, okay, so sharp corner pull. There's no control, there's no differentiation between the mouth smile left and the mouth smile sharp left. There are 2 controls pulling the mouth to the side. So you've got the mouth smile, and then you've got a sharp corner pull, which pulls the mouth corner up higher. So there's no differentiation. So I infer that, okay, well, if you're pulling the mouth smile, well, let's just go with a value of 0.3. You're going to drive the sharp corner pull at a vector of 0.3 as well. So we get a bit of sharp corner pull as well. So you can really tweak this value to change the look of the smile. Some others here I can infer. We've got mouth press left and right. Yes. Purse. So with mouth pucker and mouth closed, I use two values, and I take the difference between mouth pucker and close, and then I drive mouth purse with that final value. And I think the reason I did this, if you do a mouth pucker and mouth closed, I think it fights it. I think there's a fighting going on, which is why I subtract the two, and then I make mouth purse happen, not with one or the other value, but rather it depends on making sure that you don't have, if you have the mouth closed while you do a mouth pucker and then you drive mouth purse from that, it kind of, the lips clip through each other. So I want to do the mouth purse to only a certain degree based on how much puckering and closing that I've got of the mouth. So these are some of the things you could start to play with to kind of get the mouth to work a little bit better and not fight each other, but still get the fidelity of the Metahuman rig. Mouth funnel. Man, there are some other ones here where I infer, you get two values. Yeah, I got to find one. Maybe jaw? Left jaw right, jaw open. Ice, maybe? Oh, yeah. There's some other stuff going on here as well. So for look down, what I found was when I look down, oh, yes. I am determining a blink from somewhere. Okay, so there's a blink here. So I blink left, I blink right. When blinking, if you're looking down and blinking, it overdrives the eye looking down. And so what was happening is when you blink, because of the tracking, it also drives the eyes down when you blink. So you have this weird thing where you blink, the eyes rotate down at the same time, and it's quite once you notice it, you can't unsee it, and so you're blinking and the eyes are looking down. So what I do is I have a offset. So when I'm blinking, I'm offsetting the look down controls so it doesn't look down at the same time. So you get a more natural looking blink. So that's another thing. Man, I can't find where I've done an inferencey thing, maybe with a squint. No, these are cheek squints. Oh, yes, here we go. Here's a combination one. Okay, so when I'm doing a blink and a squint, so squinting and blinking, we do something called a lid press. So it's squeezing. So when my eyes are closed and I'm doing a squint, I want to use a control called lid press, which is squeezing the eyelids together. And that's not a thing that ARKit gives you, but when you're blinking and squinting at the same time, that is the effect of a lid press, which is how we can infer it. So without this, you don't get the fine sort of movement of the eyes. So these sort of things, you could probably play around. There are definitely ones that I haven't done. You could play around doing more of these to get more fidelity out of the facial rig. Right, so yeah, there's a whole bunch of these functions. They evaluated every tick. And then you evaluate every tick, and that's how you get the rig movements. And then it goes into modify curve. You get the value. We do ARKit transformation. So I'm taking the head rotations are also mapped from about. ARKit gives you the value from 0 to 1 for the head rotations as well, roll, pitch, and yaw. And then I normalize those as well. So it's the same thing as the others, but to do the head, you don't modify the curve values, you actually just rotate that head joint. Now, the other thing to do with the head is you should do a factor on the neck joints as well. So the head joint, you might rotate a factor of 1, but you might want to do a factor of 0.8 for the head, 0.2 for the next neck joint, and then 0.2 again for the next neck joint. So when you turn your head, it's not just one joint rotating. You're rotating the neck of the string of joints to get a better result. And then we've got the output pose. So yeah, I think that's about it. It's not hugely complicated. As I said, really, if you're doing your own level, the Puppeteer actor should give you everything that you need. You should be able to throw that Puppeteer actor into another level, and the camera should work independent. It's just how you tie the calibration UI to the player controller. So when you push 1, it brings it up, and then the calibration UI should be linked to the Puppeteer actor that's in the scene. So that's there. Oh yes, the UI as well. So we've got calibration save here. This calibration save is just is an asset that is saved to the save game. All it does is it holds 2 variables of the minimum and maximum, and the UI does all the work to do sorting out the saving. Right, UI. I don't think I'll go through this in too much detail because really the actor, that's really the main thing. So first we get a reference to the Puppeteer actor. So we go through and look for Puppeteer actor classes in the level, and then we get the first instance that we find and we set it as the Puppeteer actor. Then we set up all the blend shape widgets. So every single line is a widget on its own. So we just loop through all the ARKit blend shapes and we set the widget, and that widget looks like this. So it's just a single line, and then we just set a whole bunch of lines. And in the calibration UI, it's all in a scrolling list. And so we're just setting lots of those, adding them to the scrolling list. Then we've got a button here for saving the calibration. So we create a new save game object based on that class that I just showed you before. And we're just setting 2 variables in that class, or that object, and then we're just saving it out to a file. And then when loading, we're finding the save game name and we're loading it back in. Now you notice that the save game name is a predefined variable. So the save game is only ever 1 and it's always the same name. And it's when you load it, it's looking for that name. Once it loads it, what it's doing is it's getting the value from that save game object and then just setting the dictionaries in the Puppeteer actor for minimum to maximum. Right, so every time we click, so if we click set neutral, we're going through all the blend shapes and setting the minimum value for every single ARKit blend shape. So it goes through the Puppeteer actor and it sets the minimum value for all of them. So when you've got your neutral value, you'll have some raw values coming through. And when you click set neutral, it takes the current raw value and then sets it as the minimum. We've got auto calibrate, which we talked about before, which, you can use it if you want, have a play around. And then we've got erase calibration, which just sets the minimum maximum ranges to some value, which is just default value of max of 1, and then minimum of 0. Enabling and disabling all. So all it does is goes to the Puppeteer actor, finds the dictionary for ARKit blend shape is enabled, and just loops through and sets the values to false or true, depending on whether you've said you're setting it enabled or not for all the blend shapes. So yeah, I think that's about it. If you have any questions, just check them in the comments. I'll do my best to answer them. Hopefully this is helpful. It's probably been a bit of a long-winded video, but hopefully it helps you to have a play around. Just hack it to pieces and go to town on it. Go for it. Cheers for watching.